In our previous video, we were talking about whether accident investigations are capable of creating learning. And we were talking about the difference between learning and explaining. Explanations don't create knowledge by themselves. When we explain an accident, what we're doing is we're applying patterns. Patterns of what we see as safe, patterns of what we see as unsafe. And in fact, what accident models do is they give us a set of categories to choose from. Accident models, in fact, just create different categories. Some of them give us human error, some of them give us team actions, some of them give us the environment, some of them give us unsafe acts, unsafe conditions, some of them give us different organisational factors. But all they're doing is they're giving us this big bucket of explanations that we can choose from. And you would think of these buckets almost as like Chinese fortune cookies. We pull out an explanation, we compare it to the accident in front of us, and we apply it. Now, a good accident model will give us more fortune cookies in our bucket. It'll give us more explanations to choose from. Someone who has no training in safety, no experience in investigations, they look down in the bucket and, human error, that's all they have. Someone with a sophisticated knowledge of safety has many, many explanations they can choose from. This accident is an explanation of the theory of drift. This accident is caused by a loss of situational awareness, but situational awareness also has in here design of interfaces, glass cockpits. Different accident models, they don't take away this habit of using categories. What they do is just give us more categories to choose from. In fact, explanations prevent learning. Once you have an explanation, you don't need to learn that there are new ways that accidents can happen because you've already explained the accident with something from your bucket. So when you talk about accident investigations and you look at what are the primary factors, what's the basic problem that caused this accident? What's the root cause? What's the key findings of our investigation? All of these are ways of saying we've gone from not knowing to knowing. We've gone from uncertainty to certainty. Now, this is the opposite of learning. In order to learn, you need to start with, I don't know. Someone who pretends to know how to do something will never learn how to do it the right way. They'll never ask the teacher, they'll never ask their parents for help. They'll never go from uncertainty to true learning. And accident investigations are a great way of actually closing off that learning by saying, well, we don't need to learn anything new because we've got sufficient explanation already. Now, that may be fine because it may be that all we want to do is apply a set of categorical labels to the past. And there's nothing wrong with this. Some of these categories are really quite useful. It may be, for example, that we need to determine whether this was an accident that happened covered by the insurer, covered by work cover, covered by the employer. Those sorts of explanations are necessary. They're necessary for legal purposes, they're necessary for financial purposes, but they're not useful for learning. Now, if you've been listening to this, you're probably thinking, but hold on, I can think of examples where there've been an accident where I have genuinely learned something from an investigation. And this is certainly true. So there's got to be something wrong with my argument somewhere. And I'll point out 3 areas where, in fact, you can learn directly from an accident investigation. The first is what I think of as debugging. So we can learn that there is something wrong with a particular design, a particular way of doing operations, or a particular piece of equipment. It's fairly small learning. You've learnt, for example, that that particular wire was loose. You've now fixed it. Yeah, it was a small learning, but it was a learning. You've learnt that that particular procedure is particularly vulnerable to being interrupted and people forgetting where they're up to. That's a generalizable learning. You can do it to other times people are using the procedure. It could be that, in fact, what we do is we find patterns. So you could, for example, investigate every accident and simply record one detail. Did the accident happen during the day or did the accident happen at night? You wouldn't learn from any individual investigation, but over time you would build up a pattern of classifications which can create new learning. You could discover that 90% of your organisation's activity happens in daytime, but 60% of their accidents happen at night. This is not learning yet, but it's created uncertainty. It's created questions that need to be answered. And those questions are then the basis of learning. The third thing that happens very frequently is we learn about the normal from the abnormal. So while we are investigating, while we are classifying, we learn things about the way work normally happens that we wouldn't learn were we not paying so much attention to a particular task or a particular team or a particular type of equipment that they're using. Now, the trouble is that an accident is in fact the worst time to do this. It can happen accidentally after an accident, but after an accident, people are not normal. People are not doing the task the way they usually do it. They're doing the task the way they usually do it when they're under intense scrutiny. People are not revealing and talking about the messy details of work. They're pretending that work always happens according to plan and according to procedure. So if this is really what we want, if we really want to learn what work is really like, we can do it through accident investigations, but they're a fairly poor way of doing it. So how can we improve investigations? How can we maximize the chance that we get genuine learning out of them? The first thing is to discourage counterfactuals. A counterfactual is when you talk about what should have happened or what could have happened. If you're using words in your investigation report, like people didn't do a risk assessment, that's saying that they should have done a risk assessment. It's saying that had they done a risk assessment, things would have been safer. If you use words like only, if only they'd looked up, if only they'd paid more attention, if only they'd had more supervision, the supervisor should have paid closer attention. Counterfactuals say what could have happened and what should have happened, and in doing so, they are directly applying pre-existing categories. They're assuming we already know what should have happened, we already know what could have happened, and that assuming that we already know guarantees that we don't learn. The second thing we can do is we can ask our investigators to give us things that can be applied beyond the immediate location and circumstances. If they tell us something about what happened, ask them instead about the future. Where else would this apply? Where can this learning be used to do things differently elsewhere? And the final thing we can do is simply demand to be told new and interesting things. Stop and think, is there something that I could have known without even the investigation happening? Is the investigator telling me that humans are human? Is the investigator telling me that work has some risk associated with it? Is the investigator telling me that people can't pay 100% attention to everything every time of day? If they're telling you things that aren't new, then simply throw it back and say, I knew this. Tell me something I didn't know. Tell me something that you didn't know that you couldn't have told me without going out there into the field and investigating. And that's how we try to move from classifying and explaining to genuine learning, by making sure that our investigators themselves learn something new when they investigate.